we are welcoming our first team. AppPopuli, Rodrigo and Michal are going to present. Please come here to the stage. And yes, they are presenting a project on the health status of the poplar trees. Thank you so much.
Hello everyone, my name is Michal Wieczorek, I'm from Silesian University of Technology.
And my name is Rodrigo Arévalo. I came from University of León. Welcome everyone. Today we are going to talk about forests and new technologies. We are going to talk about AppPopuli Plus. I have to say, this name is revealing. What does it mean? App refers to application, software to use. Populi means two things. It means poplar, which is this tree that we can have implantation to achieve wood. And populi also refers in Latin to the word populi, which means for the people. So this is the application of poplars for the people. Then I have to say, we have the plus. The plus refers to neural networking, to artificial intelligence, and to new technologies.
So, what we will be talking about is, first of all, we will talk a little bit about our team, because we are a multi-international team, and also we have multidisciplinary members, because we have people that study more about trees, about ecology, about biology, and also we have a team that is from the computer science field, so we can make an app that is both good in every direction. Actually, we will talk a little bit about the challenge, so what we are trying to solve and how we are trying to solve it. Then we will show a little bit of our results, which are kind of good for what we had and short time that we had, about the feasibility, innovation, and a little bit about the history of the project.
Okay, our team was varied and diverse. We participated 9 people during this project, 6 from León and 3 from Poland, from the Silesian University of Technology. I have to say, it was necessary to have a multidisciplinary team to have ready this project. 3 people were experts on the field of forest engineering, 3 others in the field of computer engineering, and the students and mentor from Silesian University were experts in computational intelligence.
So, what was the actual challenge? So, first of all, we had an idea, a problem that was connected with forests, with public places, or just with private places, with trees and other plants. Because the problem here is that most of them, or a lot of them, can have some diseases. Either there are insect diseases, or bacteria, or viruses. So the problem is that if it is not detected and dealt with, it can be very dangerous for the environment, as it will spread to other plants. So we've decided to create a solution for that. The solution had to be easy and intuitive to use, because it is meant for people that are like normal citizens that have no knowledge about it, and also to some companies and other specialists that want to share their observations from the field into the interactive map. So that was the reason, and the challenge was to develop an app, a web app actually, also with an artificial intelligence backend that will not only allow people to share their observations, but also to automatically have given the result of what possible disease this is. We've created an artificial model that can detect over 35 different diseases, and we've achieved a very high accuracy on this model. So, I can do that.
Okay, as we have already said, The method of tackling the challenge was divided in some parts. First of all, the problems to solve was, as Michal have said, to have an application to register in real time and recognize the pests, the diseases, and the health status of our poplars, and that can be used by a lot of people, by non-specialized and also by specialized people.
Yes, so what we've done, we've created, like I said, a real-time neural network that analyzes the photos that the people can take with their mobile phones, cameras, etc., then send it to our website, and it is very quickly, like in a matter of milliseconds, analyzed, and it gives the feedback to the user about the possible disease that the tree may have, or is it okay. We've also made it intuitive and easy to use, because, as we said, it is not only meant for specialists that have knowledge about technology, that have knowledge about trees and diseases, but we also wanted to make it very easy to use for people who have no knowledge about it, just they want to upload the image, check if their trees are okay, and maybe collaborate on growing our data set to better enhance our network. We've also made it web and mobile based. So what that means? That means that it's not only designed to work with computers, however it is also very good to use on a mobile phone, and like everything with internet, like maybe also a smart fridge if anyone wants that. It was needed to create complementary information, so it is not only doing it automatic, but it also gives a very good documentation with text and images about those diseases, so the user can manually check it or be informed more about what this disease is without needing to go to Google and like check it by themselves, which can be also more inaccurate. And like it also said, there are different user profiles. So, for example, for regular citizens, it is more automated, it is less clunky, it is like more intuitive and easy to use. However, for people who are from the field, they don't need the AI, they don't need like maybe so much information, but they want easy access to the interactive map with all diseases detected in the region, and they may have wanted to have the information about the amount of sick trees and how to report it fastly. So how we approach the problem? First, we designed the app, we've designed the documents, and we've designed the rough architecture of the neural network. Then we've designed complementary materials, that means the data set, the training data set for the artificial intelligence model. So we've gathered over 1,500 photos, and this number is also growing because we've created a team that went to the forest, took a lot of photos, then we've described the photos, classified them to over 35 classes, and then we could go to the next part of the process, so the machine learning part. And in the end, we needed to validate the model, because neural networks can remember things. However, what is more important than the validation data would have very little accuracy. However, because we've designed a specific test, we could make a neural network that not only works well on the data that it's seen, but also with the new data that shows the problem. And the tests are made on the images that the network never seen, and there are no big similarities between the photos from the training set. And about the results, as I said, we've created an app. Here is the link if anyone wants to check it and use it themselves. We've created the approach of citizen science to gather the data. The artificial intelligence model had over 85% of accuracy on the validation set, which is pretty high considering that there were 35 classes and very high amount of them had very little photos, like few photos. compared to other classes that had like few hundred. And because of that, we've created a very common technique. However, it was used to the maximum because we needed to balance the data using artificially created images based on the images we had, and then we've augmented it artificially even more to create a good representation for the validation set. Then it can be integrated with the alert system because there is a map with the geolocalization of the trees with a disease, which can be checked on the site, and all the feedback from the user is sent to the server, which is then saved, stored, and shared to the others.
Okay, for the feasibility, let's talk about the feasibility. Okay, to make this plan viable, at first we had to design a work plan. A work plan according to the speciality of each person of the group. In that way, we distributed a bunch of particular dates to achieve each part of the web application. Also, to make it viable, we counted with the help and the advice of a lot of enterprises and experts in the field of forest and also of the poplar wooden plantations. In this case, we counted with the help of some experts from University of León, as well as Fernando Castedo and Álvaro González, who have a very huge knowledge about pests and diseases. And if we are making an application to detect pests and diseases, we also wanted to offer the users the information and the knowledge of different pests and diseases that we can have in our poplar fields. Also, we counted with the help of Garnica, which is one of the biggest enterprises of poplar wood in Europe, and also with some autonomic forestal organizations that are here in this autonomy of Spain. And we also have to add that this project was promoted by the enterprise Bosques y Ríos, in English, Forest and Rivers, that have marked each point that we had to have made in the application. The work plan is like this, more or less. I tell you it summarized. First of all, we worked on writing all the information of each pest, each insect, each fungi, to make the user know more about what he has in his poplar field. Then we worked on the informatics part, on the artificial intelligence part, and in the end part, we decided to make some tests with people in field of poplars, with real people trying the application and knowing how it's going, if we have to improve some part, or if some parts are already good.
And about the cost, because many of the research is not for free, unfortunately. However, we've focused on making the cost as little as possible. However, for example, we've needed mainly the cost was like for the equipment for data gathering, for the server, because this is very important to like maintain the system. However, overall, we've managed to like reduce the cost to 1,800 euros, which is not a little. However, for such big project, it is, I think, the fair cost. And yes, about the innovative aspects. First of all, we've used the citizen science approach. So we've gathered a lot of people, a lot of volunteers, and also a lot of people from our team to actually gather all the data needed, and it is growing all the time. So like in a year it could be much better. The model could have like more diseases to detect, it could be with the higher accuracy, and it could be like better overall. Also it is aimed for both specialized and non-specialized users. So it is useful for almost everyone, like we said with the populi part from the Latin, because it can be useful for companies, but also mostly for people who have no knowledge, however they want it to be useful. The multidisciplinary development is also very important because with high diversity, it is something that can benefit a lot of projects, and in my opinion, in our opinion, it should be done more often because it makes the value of such product much higher. We've also used the artificial intelligence. We've created a custom model. We've used also a very novel technique called transfer learning. So first we've trained the model on a different data set with much higher amount of classes and images, and then we've used the knowledge that the network had and fine-tuned it on our own data set, where we also used a very aggressive artificial image creation to even and balance the data set. And we've achieved a very high accuracy with it. And also this is the first app in Europe that actually provides such services. So the monitoring, the real-time usage, the artificial intelligence model that makes the detection for non-specialists more easy. So we think that this is very good, and in future we want to develop it further if possible. And such projects could benefit the environment, which is very in danger in current times. So such projects are very important for making the world a better place. And yes, about the practical applications, maybe my colleague will say.
About the practical application, as we said, it will be useful for small proprietaries and also by companies that have in control big surfaces of poplar plantations. Also, it will be useful to be used by general public, and this will allow to general people. This will allow to make them know more about pests and diseases in this world that sometimes appears difficult, but it isn't. There is a lack of knowledge in this field, and with this application, we give an opportunity to learn more about our world and our trees.
Sorry, you have to speed up.
Okay, we
How much
finish.
do we have? No.
Just
Okay, so
Okay.
actually we've ended every important part. Now we have like some photos from the data gathering. So,
give us some pictures, yeah.
okay.
Okay, these pictures are related to the test we have done in the field, because it's very important to test the application with real people in real popular fields. Last to say, if we want a Europe with zero emissions of carbon gas, we need things and use the technology in order to foment the use of wood instead of other materials as concrete, glass, or metals. In this way, this application foments this line of the European objectives, and we think it's very important to take into account society and environment in all the projects we have to our future. Thank you. This
Thank
is
you very
everything.
much for your
Thank you for listening.
attention. And are there any questions?
No, now is round for questions. Maybe Professor Nabil is going to start with the first one. Thank you for that.
So,
Yes, one minute. Can the whole team go up on the stage, please, for this part? Because I think it's for the best if you can all answer the questions. Thank you.
So my question is, how does your system effectively identify and report the health status of popular disease in real time based on observed symptoms?
It works in that way that there is the web app, and the person could like go to the forest, take a photo of the leaves of bark or the tree like entirely, and then it is uploaded to our server where there is the neural network, and it uses artificial image processing to like detect to those 35 classes, and it tells that with a probability of, for example, 70%, this is this disease, it may be this disease in, for example, other 30%, and if it's not sure, then the probabilities are very low because we have like 35 diseases, however there are many more, but during the time of the project we could only manage to select and like find only those. However, in the future, if more people like uses this app and we could analyze more photos, the dataset could be easily expanded to like 40 classes, 50, 100, and then trained to detect more things, and also with higher accuracy and with worse scenarios. So it works in that way, and then the result is sent back to the user like in matters of few seconds or sometimes even less.
Okay, thank you very much. Now, Professor Neil Petrisan.
I have a lot of questions. It's a real problem now for forest. Okay, maybe we can discuss later, but one question is, did you make an analysis between the disease or the pest and the factors and the relation with the environmental changes? So the idea is for future work to make a prevent to avoid some diseases development.
Exactly. This application, for example, will be available to be mixed with an integrated system via satellite that check the images.
Like the leaders?
Like not LIDAR, but for example, Sentinel or that kind of satellite images that can provide information about the conditions of the poplar, of humidity, of vitality, and this application will be able to be connected with that to mix the knowledge of one and other technology, and in that way know what is causing the prevalence of some plague or disease in each part of the surface of the poplar field.
Okay, so now Professor Marcin.
Thank you. Simple question. How are you gonna make money out of that?
That's not the idea. The idea is to provide people a free tool to achieve these things. When we talk about society and benefits, we don't talk about money. For example, in Spain, the line of trains we have are not profitable talking about money, but it's a very useful tool that if we didn't have, we couldn't live well. So this is not for earning any money. What do you think, guys?
However, if it's, for example, we want to make it more private or use a company or create a company, then, for example, it can be free to like most of the users. However, there may be like some additional payment for enterprises or for big companies, so they can have, for example, like some applications like TeamViewer, etc., are free for private use. However, for companies, they must pay like a small subscription fee or a small one-time fee. And also, to make it more beneficial for people who pay for it, we can create a small like technical support, or they can create their own like little data set of some diseases and give it to us, so we can retrain the model to also include their needs.
Yes. Thank you.
Okay, so now it's my turn. Have you considered creating field tests for the cases in which your algorithm doesn't work.
Yes, exactly. It works in
Yeah.
that way. We have if for someone who don't know the names of the diseases, there is like a list of the most common diseases in this area. And for each of these diseases, we have like a text document with some images to like tell what this disease is, how to fight it, and some description and what to do. However, for people who doesn't know or that don't want to read it, then there is the artificial intelligence model which does it automatically. And in case the specialist uses this app, he can write it the name not from the list manually.
Who you is the specialist in artificial intelligence?
Mostly me and Jakub.
So is this far away from Google Lens technology?
It's a little bit different. Like Google Lens does know about, can detect what kind of plant it is. However, it does not. It was not trained on diseases, and we are not focusing on what plant it is. However, we are like after taking a photo of the leaf, it has some like bruises. It has some different colors in some places, or some insects, and the network detects that things. So it is similar, however it is trained on different things. So it is not
much better.
For this case it is much better because we know what disease is it, and with Google Lens we don't know.
Okay, thank you very much.
Thank you.
Thank you.
We're running out of time. So